Okay, good day class. So today we're going to have a discussion or in continuation of the discussion regarding the equilibrium constant as well as proceed na rin doon sa Le Chatelier, which is the next topic of our discussion. Okay? First, what is equilibrium position? So equilibrium position, according to this, sabi niya, it is a qualitative indication of the relative amounts of reactants and products present when a chemical reaction reaches equilibrium. And equilibrium position either be favoring the right side or yung products mo, or the left side or yung reactants mo, or neither of those two. And yung pag-favor na yan, it depends on the computed value of K, which is your equilibrium constant. Okay? Now, this is the magnitude of the equilibrium constant. Okay? When your computed value is basically more than 1, no? Pag mas mataas sa 1 yung computed value mo, that means the equilibrium favors right, which is your products. Or pwede mo ring i-observe, no, kapag before you compute the actual equilibrium constant value, observe mo rin na when the numerator or yung product side is larger, di ba? Yun nasa taas. Pretty much, no, you're pretty sure na your equilibrium will favor the right side or yung products mo. Whereas naman, kapag the equilibrium constant computed value is less than 1, so basically those that are, your result would be 0.9 pababa, no? So if it is less than 1, meaning the equilibrium favors the reactants, no? Or the equilibrium favors the left. And again, if you observe the numerator and the denominator value, kapag yung denominator mo or yung reactants yung nasa baba is pretty much larger, no, yung value niya is larger than your numerator, then you will have an idea that your equilibrium favors the left without computing yung yung equilibrium constant. Okay? And lastly, this rarely happens, pero sulat na rin natin dito, when the equilibrium constant is approximately equal to 1, okay, ibig sabihin nun, both your numerator and denominator are almost equal. So both reactants and products are present at equilibrium. So it neither favors left nor right. Okay? So ito po yung shortcut version. Again, if your equilibrium constant is greater than 1, it favors the product side, or the equilibrium lies to the right. Okay? And then if your computed value for equilibrium constant is less than 1, so your equilibrium favors reactants, or the equilibrium lies to the left. And lastly, if your equilibrium constant is equal or approximately equal to 1, both your reactants and products are present at the equilibrium. Hence, it neither favors or it neither lies to the right nor to the left. Okay? So, this next slide naman, just to give you an idea on the extent to which the chemical reaction has taken place due to your equilibrium constant values. Okay? You don't need to memorize all of this, no? Kasi obvious naman na if your equilibrium, yung value mo for your equilibrium constant is very, very large, no? Umabot na ng millions, ng billions, no? Ibig sabihin, sobrang layo niya na. It is too far to the right. Whereas naman kapag your computed value is very, very small, 0.000, sobrang daming zeros, and up until the actual absolute value. So basically, it is far to the left, no? And this, again, you don't need to memorize this table. This is just to give you an idea, no? Equilibrium constant mo. Okay? Okay, now let's calculate na, no? So the problem is here, calculate the value of the equilibrium constant for the equilibrium system, iodine plus chlorine, reversible reaction into a iodine monochloride. Okay? Tapos yung problem niya dito, at 1000 degrees Celsius given the equilibrium concentrations are 0.0025 for iodine, 0.0012 molar for chlorine, and 0.071 for iodine monochloride. Okay, so meron na tayong mga given values or equilibrium concentration per compound, no? Now, what we need to do here is to given. Okay? Ano ba yung mga given natin? Okay? So, given for your iodine, ano sabi niya dito? Iodine, 0.0025 molar. Ang chlorine niya naman is 0.0012. And lastly, your iodine monochloride, 0.007. Now, before we proceed to the equilibrium constant, no, if you recall our previous topic, ano yung pinaka-important? What is the most important thing first that you need to do prior to the computation? Okay, if you remember, ano ba sinabi natin? Sabi natin, you need to balance the equation. Okay? So, as you can see here, meron tayong mga subscript na 2. Okay? 2 for iodine and then 2 for your chlorine. So, if we need to balance that, ano yung magiging, complete chemical equation for a balanced equation? So, iodine, chlorine, reversible reaction with iodine monochloride. So, since there are 2 subscripts per iodine and chlorine, maglalagay ka lang ng 2 coefficient dito kay iodine monochloride. So, basically, you already have a balanced equation here. Okay? Now, let's proceed na dun sa ating okay, sa computation na. So, if you remember, sino yung sa numerator? So, numerator would be your so yung numerator mo would be your product. So, ano ba yung product natin? 2 monochloride. So, basically, yung value niya, which is 0.007, and then since we have a coefficient of 2, so, magiging, maglalagay ka niyan ng superscript dito, no? Kung ano yung coefficient value niya. Okay, so, ibig sabihin, meron siyang exponent na 2, okay, to the power of 2. And then, sa inyong denominator, syempre, yung reactants mo. So, you have 0.0025 and then 0.0012. Okay, now if we compute that, makukuha mo. So, you try to compute this formula as well. Okay, so if na-compute nyo na, again, meron siyang squared, no? So, 0.007 squared is 0.000504. And then, sa denominator mo, 0.0025 multiplied by 0.0012, you will get 0.0000, daming 0, tas 3. Okay? Now, if you divide that, ang makukuha mo would be 16.8. Okay, so basically, that is your equilibrium constant value. And as you can see, it is greater than 1. So, if the computed value is greater than 1, it favors the products. Okay? Ibig sabihin, left or right? So, it is right. The equilibrium lies the right side kasi it favors the products. Okay? So, ganun lang siya kasimple, no? Kung yan lang yung computation for the equilibrium constant. Okay, ayan, no? So, pinakita niya to balance the equation. Ayan, ganyan. Okay, so given, tas, ayan. Okay, 16.8. Favors right. Okay, next. Let's try to compute this one naman. So, consider the equilibrium system. You have a carbon monoxide plus the oxygen gas. Reversible reaction to CO2, no? Carbon dioxide. What will be the equilibrium constant if the equilibrium concentrations is 0.0098? Okay, let's try to compute this one. 0.0098 molar. Oxygen is 0.0021 molar. And carbon dioxide is 0.525 molar. Now, if you are capable of computing this, no, using the scientific calculator, no, straight up, that is fine, no, as long as you obtain the equilibrium constant value or malapit naman siya doon sa computed value, no. So kasi 'di ba, if you compute this straight, no, dire-diretso, ang value mo is the exact value. However, if you compute it ng isa-isa, step by step, okay, syempre, you need to what you call this, you need to round up yung mga mag-round off ka muna ng mga values. So, medyo iba yung value. So, regardless, as long as the final answer is near to the correct answer, that is fine by me. Okay? Okay, again, first things first, we need to assess if the equation is balanced. So, COO2, O2. So, hindi siya balanced, no? Kulang tayo ng sobra tayo ng isang oxygen sa isang side. Okay? Okay. So, paano yan? Lagay ka lang ng 2 dito, dalawa na yung carbon mo, tas 4 na oxygen. Okay. So, you just add the coefficients. Balance na ba yan? Oxygen is 1, 2, 3, 4. 1, 2, 3, 4. And then yung carbon is 1, 2, 1, 2. Okay? So, we already have a balanced equation. Now, the next step is lagay mo lang tong K. Numerator. Sino yung nasa numerator? The product. So, 0.525 and then you include the coefficient. 2. And then your reactants sa baba. Carbon monoxide is 0.0098. Tapos 2. Oxygen is 0.0021. Okay. So, next, ano yung value niyan? The value is, again, if you already have this, yung given na ilagay nyo na sa numerator and denominator, you can compute this step by step or straight up sa scientific calculator. So, regardless, as long as you have the correct answer, that is fine by me. Ay, bakit mali-mali. Sorry. 0.275625 over 0.000. Ilang zero to? 6. 201,684. Another thing is if you already know how to utilize scientific notations, no, para hindi ka nagsusulat ng maraming zero, that's fine also, no. Ang pinaka-importante lang dito, so regardless, is the computed value is correct or it is near the correct answer. No, hindi siya malayo. So, the answer is 1,366,618 point something. Okay? So, again, as you can see, the computed value of the equilibrium constant is very, very far from the from 1. Okay, it's greater than 1, so it favors, so equilibrium constant is greater than 1, so favors the products, so it lies to the right. Okay, so ganun lang yan. Check natin if tama. Okay, so balancing, computation, so favors right. Okay, next. Now the question here is, what if the equilibrium concentrations of each compounds are not given sa problem, no? So if that particular problem di binigay yung equilibrium concentrations, we need to perform the ICE, or yung initial, change, and equilibrium. So it is a simple matrix that is used to simplify the calculations in reversible equilibrium reactions, especially utilized sa weak acids and bases and complex ion formation. Okay, so basically ito yung magiging foundation. This will be the foundation of some of your clinical chemistry computations. Okay, so in the future, ma-appreciate nyo kung bakit natutunan nyo to. Okay, so it is composed of concentrations of molecules in solution in different stages of reaction. Yung stages, yung initial, yung change, and then lastly the equilibrium. Now, let's try for the first problem. Sabi niya, using the ICE method, determine the equilibrium constant of the given equilibrium system. Okay, so 2CO2, carbon dioxide, reversible reaction sa carbon monoxide plus oxygen gas. So, as you can see, in this case, no, binalance niya na yung equation natin. So, we don't need to balance it anymore. However, again, if it is not yet balanced, the chemical equation is not yet balanced, you need to perform balancing. So, to continue, so, where a sample of carbon dioxide consisting of 0.500 molar is placed into the system with a volume of 0.750 liters. At equilibrium, the amount of carbon dioxide is known to be 0.350 mole. So, how do we do this table? So, first, you input yung mga reactant. So, ito, reactant niya, isa lang. And then, products. Okay? Now, the next step is assess sino-sino yung mga present during the initial. Okay? So, if we go back to the problem, where a sample consisting of 0.500 mole of carbon dioxide. So, meron kang initially, you have a 0.500 moles of carbon dioxide placed into a system with a volume of 0.750 liters. This will be utilized later. Take note lang yan. So, in initial, we only have carbon dioxide concentration. So, if yun lang if that particular compound lang yung nakita mo or yung present sa problem, automatically, zero na yung other other compounds. Okay? So, wala na silang laman initially. Okay? Now, at equilibrium, the amount of carbon dioxide is known to be 0.350 mole. So, at equilibrium daw, okay, yung carbon dioxide is 0.350. So, basically, we need to find out yung change ng dito, change, yung tatlong change, and then yung equilibrium amount of your carbon monoxide and your oxygen gas. So, yun yung mga missing. Okay? Okay. So, first, we need to compute for the change. So, equilibrium amount, so ito, this one, the formula is initial amount plus change in amount. So, you have 0.500, wala ka dito sa change, and then you have 350 here. So, how do we compute for change if this is the formula for equilibrium amount? So, basically, to compute the change, you will have equilibrium minus the initial amount. So, equilibrium amount minus the initial amount, you will have your change. Okay? So, 350, 0.350 subtracted by 0.500, you will get a negative 0.150. Okay? Now, next. Yan. So, you have 0.500 negative 0.150 0.350. Okay. Now, to compute for your change in product, you refer to this formula. So, change in product is equal to the negative coefficient of product over the coefficient of reactant multiplied by the change in reactant. So, isa-isa natin yan. So, one by one, we need to compute for the change. Okay? So, yung change here sa carbon monoxide. And then yung change here dito sa oxygen gas. So, first, let's compute for the change in the carbon monoxide. So, sabi dito, change in product is equal to the negative coefficient of the product. What is the coefficient of carbon monoxide? It is 2 over the coefficient of reactant. What is the coefficient of carbon dioxide? It is 2. So, ayan, 2, 2. Sorry. Yusin natin. So, 2, yun, and then 2 sa baba. Okay, tapos, sabi niya, multiplied by the change in reactant. So, this is the one. So, negative 0.150. So, basically, you have negative 1 multiplied by negative 0.150 for the carbon monoxide. So, if you compute that, ano makukuha mo? You will get, wait lang, tanggalin lang natin to. So, again, negative 2 over 2 times negative 0.150 negative 1 times 0.150, you will get a positive 0.150. Okay? So, that is your change. Gets? Now, let's try to compute naman dito sa oxygen. So, in oxygen, na makukuha natin would be, wala ba ako eraser dito? Positive 0.150. Okay. In the next one naman, sa oxygen, negative coefficient of your product. So, wala. It is 1. Coefficient of your reactant, 2. Again, multiplied by negative 0.150. So, you have 0.5 negative multiplied by 0.150. So, what is your computed value here? Your value would be 0.075. Okay? From that point, meron ka ng change. Diba? Kompleto na yung change mo. You have a complete change for your ice table. So, ano na lang yung yan. Ano na lang naiiwan ngayon? So, what's left now is your equilibrium amount. yung sa pinakababa. Again, if we go back to your previous slide, sabi niya, equilibrium amount is equal to the initial amount plus change in amount. So, simply add yung 0, ito, initial amount, plus itong 150. So, you get 0.150. Again, dito, 0 siya, yung initial niya. So, you have 0.075. Okay? So, basically, linisin natin. Okay? So, 0.500, 0.350. Quick review. So, subtract lang. So, negative 0.150. U by 0, 0 hito. Then, compute 0.150, 0.075. Pag-add mo lang, you'll get 0.150 and then 0.075. So, the next step would be, we will now utilize itong volume of the system to compute for the equilibrium concentration for each compound. Okay? Now, we have the value here, 350, 0.150, and 0.075. So, the formula there is, hindi niya binanggit dito. Ayun, yan. So, the formula here would be equilibrium concentration of a substance is equal to the amount of the substance in equilibria over the volume of system. So, yung computed value mo here will be divided to the volume of system. And from that note, you will get the equilibrium concentration for each compound na gagamitin mo for the computation of your equilibrium constant. Okay, so medyo mahaba, I know, but it is a step-by-step process which are important, no, each and every step. Okay, so let's try to compute. So for 2CO2, you get 0.350 over 0.750. See, carbon monoxide, you'll get 0.150 over 0.750. And then lastly, yung oxygen gas, you get 0.075 over 0.750. Now, you compute all of this, no? Again, saan natin nakuha yung numerator and denominator? Ayan. Equilibrium concentration of a substance, amount of substance in equilibrium, ayan, yung pinaka-last na row, and then volume of system, which is found in your problem. So, in this case, 0.750. So, we divide all of that, each of that, so you get dito 467, ay, may nakasalabat, wait lang. Yan, dito na lang. 0.467 mole. And then dito, 0.2 mole. And then 0.1 mole. Okay? Now, so we have now the equilibrium concentration for each compound. So, dito pa lang natin pwedeng i-compute yung equilibrium constant. Okay? So, ayan. Ayan, nakuha natin. So, to compute for your equilibrium constant, again, gagamitin natin yung formula. Okay? Ready? Now, yung numerator mo would be your products. So, what are your products? You have a carbon monoxide, 0.2, tapos yung coefficient niya, and then your oxygen, 0.1. And then, your denominator would be your reactant. So, 0.467. Okay? You try to compute that, no? Ay, 0.467 tapos 2. Yan, sorry. Now you try to compute that, you will get 0.004 and then 0.218089. Your computed value will be k is equal to 0.018. So basically, equilibrium constant is paano ba? Less than 1. So basically, it favors the left side or your reactants. Okay? So, ganyan, no? Ganyan kahaba yung ICE method to compute your equilibrium constant. Okay? So, if you have any questions, just email me, no? Then, we'll proceed to the next slide. Now, pag medyo malabo pa, if it is very difficult to understand, you just rewind this video tapos play nyo ulit. And then, again, mahirap talaga. So, you need to practice more. Okay? Okay, now let's try to compute this one. No? You can pause the video to practice on your own. Tapos, you try to compute this problem then by yourself. Okay? Okay. So, now let's proceed. So, ayan, ito tayo. Ayan. Using the ICE method, determine the equilibrium constant of the given equilibrium system. Ammonia, reversible reaction into a nitrogen gas and hydrogen gas. For samples of 0.350 ammonia, so initial na to, no? So 0.350. So meron tayong NH3 dito, tas N2, and then H2. Okay? So balance na ba yan? So balance muna natin. NH3, N2 plus H2. So lagay ka ng, so we need 2 nitrogen. So lagyan tayo ng 2. So 2 nitrogens. So you now have 6 hydrogens here. So we need 6. You just add 3. So 3 and then 2. Okay? So it is already balanced. So let's go back to the problem. So 350 molars of ammonia and 0.720 nitrogen, 720 and 0.688 moles of hydrogen. Ay, wala yung, ba't kulang yung ano? Okay, wait lang guys. Okay, sorry, naputol siya, no? Pero dito at equilibrium, the amount of the ammonia is 0.336 daw. Okay, so 0.336. Okay, so compute, subtract this, you have 0.014. Tapos, again, to compute for your change in product, yung coefficient ng product mo over yung coefficient of your reactant, negative 0.14. Yung isa naman is negative 3 over 2 times negative 0.14. So yung value dito sa nitrogen is 0.007 positive and 0.021 positive. Okay? And then add mo lang yan, you will get 0.727 and 0.709. Okay, di ba? Ganun lang kasimple. So, kanina, meron lang tayong values nito and ito. So we got this by subtracting yung equilibrium minus yung initial. So nakuha natin yung change. And we got this by yung formula for your change in product, which is yung coefficient of your product over coefficient of your reactant multiplied by the change in your reactant. Okay, so the computed value here is 0.07, tas sa kabila naman is 0.021. The equilibrium amount is initial plus change. So pag pinag-add mo yan, you will get 0.727, and then here is 0.709. Okay, so your table would look like this: 2NH3 0.350 0.336 and 0.720 0.007 0.727, and then lastly 3H2 0.688 0.021 and 0.709. This is 21, 21. Okay, now to compute for your equilibrium concentration for each of the compound, NH3 is equal to, okay, so dito is 0.42. Wait lang. Okay, yung equilibrium amount over yung volume of the system. Ito. Okay? So, kuha mo is 0.42. Tapos si N2 naman 0.727 over 0.800. Ang makukuha mo would be 0.909. And lastly, yung hydrogen gas, you have your 709 over 0.800. Computed value is 0.886. Okay? So, ito na po yung mga equilibrium concentrations for each of your compounds in the system. Okay? Now, let's try to compute na yung equilibrium constant of the equation. Okay? So, barayin muna natin lahat to. Yan. So, equilibrium is equal to, sino yung products mo? 0.909, 0.886. And again, may coefficient na 3. So, 3. Then sa baba, reactant, you have your 0.42. Coefficient 2. So, compute mo yan, you will get 0.6322 over 0.1764. So, you divide that, you will get equilibrium is equal to 3.58. So basically, your equilibrium constant is greater than 1. That means it favors your products. So basically, it lies to the right. Okay, for the last example, you try to compute this on your own. You may pause the video to answer or to complete the table. Reminders, you balance the equation first. Pero as I can see here, it's already balanced na, no? So, you balance the equation. Tapos, you write the given. And then, you complete the table. Okay? Now, if your table looks like this, that means you're correct. So, you compute for the equilibrium concentration for each of your compounds. Okay? So, may answer ba ako? Wala. So, let's try to answer the equilibrium concentration for each compounds. So, 418 over, ano ba yung volume of system? 2 liters. So, 0.418 over 2 over 2 and over 2. You will get 0.209. Dito naman ay 0.05675 and pareho lang. Okay. The next step, yung last step, would be compute for your equilibrium constant. Dito. Okay, na-compute nyo na ba? So, if your computed value is 0.0737, ganyan. Basta malapit sa answer na yan, that means you're correct. So, your equilibrium constant is less than 1. So, again, it favors your reactants. Favors reactants. The equilibrium favors or lies to the left. Diba? So, ganun lang siya kasimple. So again, if you have any questions, don't hesitate to email me, or you can also recall or review, on our next face-to-face meeting. Okay? So now let's proceed to the last topic, which is the Le Chatelier's principle. So in this case, we are going to apply the principles that we have learned previously from the chemical reactions, yung mga temperature, concentration, volume, pressure, and etc. Okay? So, when we talk about Le Chatelier's principle, it tackles the changes in your equilibrium. There will be an exact change on the equilibrium shift kapag you added or you removed certain factors such as your concentration, temperature, pressure, or volume. Okay? So, for example, ito. First one is concentration. So, in concentration change, okay, yan. As you can see, if you add addition of reactant, the equilibrium shifts to the right. Okay? So, if you add the concentration of your reactant, okay? Nasaan ba yung reactant? Left or right? Diba? Nasa left siya. So, magko-compensate ngayon, there will be a compensation doon sa right side, doon sa product side. Hence, the equilibrium will shift to the right. Okay? Whereas you remove or you decrease the concentration of your reactant, the equilibrium will shift to the left. Nagbawas ka eh. you remove a certain amount on your reactant side. So the equilibrium will shift to the left. Okay. If you add a product, so again, product side, nasa right side yan. Diba? Of your equation. If you remember, A plus B, C plus D. Okay? So if you add a product, in this case, nandito, nagdagdag ka, increase the concentration, the equilibrium shifts to the left dito sa kabila. Okay? There will be a compensation. Dinagdagan mo yan, magdadagdag sila dito, or there will be a compensation in this equilibrium. Okay? Kabaliktaran, kumbaga. If you add a reactant, mag-shift dun sa right. Okay? If you add a product, it will shift to the left. Okay? Now, removal and decrease of product, on the other hand, will shift to the right. So, nagbawas ka ng product, syempre, the equilibrium stays in the product side. Okay, so ganun yung concentration, no? Again, concentration change, reactant, nagdagdag ka, it shifts to the right. Okay, compensate yung kabila. If you remove or you decrease the reactant, yung reactant mismo, doon yung equilibrium. So, it shifts to the left. You add a product, you add concentration in the product, it shifts to the left. Compensation. And then, if you remove or you decrease the concentration of a product, magstay dun sa exact sa product mismo. The equilibrium will stay to the product side, which is the right side. Okay? Next. Yan. For example, this one. Increase the carbon monoxide concentration. So, as you can see, nasaan ba si carbon monoxide? Nasaan ba si carbon monoxide? Nasa dito. So, it is in the reactant side. Yung ibig sabihin, if you add a concentration in the reactant, the equilibrium will compensate dun sa product. So, it will shift to the right. So, tama ba tayo? Yes, correct tayo. Another example, if you remove the oxygen concentration, so again, nasan ba si oxygen? Reactant or the product? Nandun siya sa reactant. So, the equilibrium stays or shifts to where the reactant is. So, it shifts to the left dito. So, let's check if we're correct. Yan, tama tayo. Okay? Next, what if we decrease the concentration of carbon dioxide? So, this is your carbon dioxide. You decrease the concentration. Carbon dioxide is your product. Pabababain mo daw. So, it shifts to the right. No? Dito pa rin. Okay? Yan. Correct tayo. And lastly, you add the concentration of your carbon dioxide. Again, dinagdagan mo yan. Compensate yung kabila. Shifts to the left. Okay? Diba? Ganun lang kasimple yung concentration changes. The Chatelier's principle. So, the next one is the temperature changes. In this case naman, we classify first if it is a endothermic or an exothermic reaction. If you recall, if we talk about endothermic reaction, no, ibig sabihin DR or the reactant side. Okay? Exothermic naman, XP, ibig sabihin the product side. Okay? So, endothermic, when you increase the heat, ibig sabihin, the equilibrium shifts to the right. Kapag naman you remove the heat or you decrease heat on endothermic reaction, the equilibrium shifts to the left. Okay? Kapag naman exothermic, if you increase heat, it shifts to the left. Kapag you remove or decrease heat, it shifts to the right. Okay? Now, sorry, lumitaw yung answer. Now, as you can see, in this chemical equation, no, yung reactant mo, two separate sila. Combination reaction. And then yung product mo, iisa lang. So basically, what happens here? There is a formation, no, of bond. And ano kasi yung formation? Formation of bond sa exothermic yun. So XPF, tandaan nyo rin yan, ha? Kapag naman endothermic, it is breaking ng bond. So kabaliktaran nito, yung ammonia nag-disperse ng nitrogen gas and then hydrogen gas. So DRB. Yan, para meron kayong simpleng alalahanin. Okay? Endothermic reactants, breaking of bonds, exothermic products, formation, non-formation. So as you can see here, there is a formation between the nitrogen gas and hydrogen gas, naging silang ammonia. So basically, if you increase the heat, there will be the equilibrium will shift to the left. Okay? And if you decrease the temperature, since this is a exothermic reaction, the equilibrium shifts to the right. Okay? Ganun lang siya simple. Next, pressure changes. In pressure change, if you increase the pressure, the equilibrium will shift to the fewer number of moles. Okay? So, if you decrease the pressure naman, it shifts to the side with more number of moles. So, increase, fewer number of moles. Decrease, more number of moles. So, in this case, you count the moles for each side. Okay? So, ganun mo lang i-base yung pressure change. So, pressure changes solely works in the chemical equations in gaseous form. So, again, that's why we remove pure solids and pure liquids in our equations, right? If you remember that. And pressure and volume have an inverse relationship according to Boyle's law. So basically, if there is an increase in pressure, that means the volume will decrease. No? Increase pressure, decrease yung volume. And if you have a decrease in pressure, there will be an increase in volume. Okay? Next. Yan. For this example, increase yung pressure of this whole system. Again, you count the number of moles. So, you have 1 and 2, that's 2. Okay? So, 3 dito, tapos 2 lang dito. So, 3 dito, and then 2 dito. So, if you increase the pressure, you shift to the fewer number of moles. So, since dito, dalawa lang, the equilibrium will shift to the right. Okay? So, ganun lang kasimple. Now, if you increase the volume, again, it is inversely proportional to your pressure. So, babaliktarin mo lang to. Increase in pressure, shifts to the right. So, increase in volume shifts to the left. Diba? Ganun lang kasimple. Okay? So, let's try to apply Le Chatelier's principle with this given chemical equation. You may pause the video. You can try to answer this on your own and then let's try to check. Okay? Okay, game. So, the answers to number 1 ay to letter A, increase hydrogen iodide concentration. So, hydrogen iodide, nandito yan sa reactant side, on your left side. So, according to this one, increase. So, if you increase this one, ano bang review natin earlier? We said earlier na magko-compensate yung kabila. So, the answer here is, it shifts to the right. Okay? Next, remove the heat in the system. Now, we need first to identify if this is exothermic or endothermic reaction. If you remember, is a compound, and then ang nangyari, it breaks into a hydrogen gas and the iodine on a gaseous form. Okay, so endothermic reaction, and then if you remove the heat on endothermic, diba? DRB. So endothermic reactant, breaking of bonds. So you remove that shifts to the left. Pag naman nag-increase, shifts to the right. So basically, nag-remove ka or decrease temperature, it shifts to the left. Next, if you add pressure in the system, now let's count the moles. So 1, 2. Tapos meron siyang 2. Sir, pareho lang siya. So if the answer is pareho lang, you don't answer neither. You choose the fewer number of compounds naman na present. Since here, isa lang yung compound mo, dito, dalawa, the answer is nandito. Okay? So, mas konti dito sa left side. There is a fewer number of moles on the left side. Hence, the answer here is left. And of course, increase yung volume. So, if you increase the pressure, left, increase the volume, that means there's an inverse relationship with your pressure because of Boyle's law. So, the answer is right. And lastly, you add catalyst in the system. Nasa Le Chatelier's ba yan? The answer is no. Pero nasa reaction rates na pinag-usapan natin earlier. And if you add catalyst in the system, it only hastens the chemical reaction of the whole equation, no? So there is no effect in the equilibrium position. So the answer is no effect. And then this is the whole summary of your equilibrium and Le Chatelier's principle. Okay, and that's it. So if you have any question, you don't hesitate to email me here, no? how.edu.ph. Okay? You can email me here. Tapos, if you have additional questions pa, no, to clarify. I know that this is a difficult topic, no? So, you just ask questions, don't hesitate. And then, kung marami pa, next face-to-face meeting, we could recall or review certain topics, no? Okay, so again, thank you. I think this is the last slide. Yes, this is the last slide. So thank you and God bless. I will post additional supplemental videos, no? Kasi it's pretty hard for me to discuss in online. Mas gusto ko sa whiteboard. Okay, thank you and God bless.